A is a straight chain hydrocarbon with the molecular formula C5H12. State one natural source of hydrocarbons and two possible uses of compound A. What do you guys think? So sources of hydrocarbons, that's a topic that'll come.
Fossil fuels.
Well, more specifically,
That's natural gas and petroleum.
right, more specifically, natural gas or petroleum. Remember, you have to state one. Always remember to read and comprehend your question. So you're stating one. State two possible uses of compound A. What's the name of compound A? First thing you should identify. To what homologous series?
Pentane.
Pentane. So what's homologous series? Alkane. Good. So it's an alkane, and specifically it's pentane. So what are two possible uses of this compound?
As
What's that?
best as fuel.
You can have fuel, so it's, okay, compound A can be used as one, a fuel, and two, okay, so pentane specifically can be used in the manufacture of plastics. Okay, so pentane specifically can be used in the manufacture of plastics, polystyrene, foam, which is styrofoam, right?
Yes, yes.
Other uses, it can be used as a solvent or lubricants, all right? Alkanes in general have those uses. Draw the fully displayed structure of compound A. So this should be easy by now. It is C5H12. So you draw out your carbons and then you fill in the hydrogens. Don't leave them unfilled. I know it's easier when you're studying, but you have to put them in. Right? And of course, alkanes are the easiest ones to draw. It's just carbons and hydrogen. Understood? Good so far?
Yeah, miss. Yes, miss.
Part B, thermal and catalytic cracking are very useful processes in the petrochemical industry. So part 1, define the term catalytic cracking. Tyler, let me hear you.
Miss, when vapor passes through a low density catalyst.
Well, of course, yes, you're going to be using a catalyst because it's catalytic cracking. But remember that cracking is really the process where you're breaking up large molecules into smaller ones. So in this case, catalytic cracking means that you're using a catalyst to do so. All right, so this is the process which uses lower temperatures and a catalyst to split large molecules into small molecules. Remember that? And thermal cracking means that you're using high temperatures. There's a difference. Number 2, state the importance of catalytic cracking in petroleum refineries. All right, it provides a source of alkanes and alkenes as fuel. So remember, like I just explained, cracking is a process where you're breaking up those large molecules. So these large molecules can have up to 20 plus carbon atoms. But when they crack them, you get smaller chained molecules, which would be like pentane and so on. And even alkenes are produced in this way. So you get both alkanes and alkenes. And in petroleum refineries, they can use that now as fuel to do their processes. Make sense?
Yeah.
Yes, miss.
Part C, another hydrocarbon, compound B, with the formula C5H10, can be converted to compound A in a simple one-step reaction. Part 1, draw a possible fully displayed structural formula of compound B. So compound B they give you the formula there, C5H10. So notice that with the alkane, you already have 5 carbons here, but it's 10 hydrogens, not 12. So we're going to have to remove 2 of those hydrogens from the alkane. So we remove 2 hydrogens from there. Now remember, each carbon atom has to be bonded to 4 other things. So in this case, because we remove those 2, we have to have a double bond here for that to be possible. So C5H10 is an alkene. All right, you guys would have figured that out in your head? Yeah, no?
Yeah.
Yes,
Yeah.
miss.
All right, good. So it's an alkene. State one physical property common to both compound A and compound B. So between those 2 compounds we just saw, pentane and pentene, what is one physical property common to both of them?
They have 5 carbons.
Correct. So they both have the same number of carbon atoms. Okay, compound A and compound B can be distinguished by reacting them with bromine solution in the dark. Part 1 states which of the 2 compounds, A or B, reacts with bromine. So just a refresher, compound A is pentane and compound B is pentene. Which of those would react with bromine?
Would it be the second one? Pantene, I believe this was called.
B, yes, pentene, the alkene, right?
Yes, miss. Yes, miss.
Yes, so it will be B because it's an alkene. Alkenes react with halogens. Part 2, state the color change that is observed when the reaction occurs.
So it's in color.
Okay, so what's the color of the bromine? Remember?
Like orange.
Yeah, you can put reddish brown or orange to colorless. All right, so that's the color of bromine naturally is reddish brown or even in solvent, close to orange. Well, when it's reacted and all of the bromine is used up, so remember the bromine will be, when the chain and the alkene is broken, it will be added there. So it becomes a halogenoalkene, right? And that will be colorless. So once that reaction is done, it will be colorless. Write a balanced chemical equation for this reaction. C5H10 plus Br2, and that'll give you C5H10 Br2. All right, remember it's an alkene. Because it's an alkene, that double bond is being broken. It's an unsaturated bond. So think about what saturated means. Saturated means it can no longer hold any more bonds. It can no longer have any more bonds. So that would be like an alkene that is saturated. All right. Now, an alkene, because of the double bond, we call it unsaturated because the double bond can be broken for other things to add to that compound. All right. So the number of hydrogens in the alkene would not change because it's the double bond that is breaking and the Br2 would be being added to it. So let me show you here. This is the double bond that is going to be broken. Once that is broken, this will just turn into one bond. So you'll remain with one bond there. And now the Br2 will be added onto it. Understand?
Yes, miss.